Hello students, welcome to physics class. Myself is Mr. Sanaullah Khan and CMS Java. Today we are going to start chapter number 2, units and measurement. In second video we have just reached up to the parallax method. Just after this our new topic is dimensions and dimensional analysis. So let us go through this topic, dimensional analysis. What do we understand by dimension? Dimension means we have already studied about the physical quantity. Dimension means the powers over a physical quantities. These are said to be the dimension of physical quantity. Suppose that we take mass, we take length or time, okay, and any quantity, derived quantity which is made by the fundamental quantity. We take area. Area is made up of length into breadth, okay. 2 times length are there. So if we multiply length into length, we will get L square, and L square means L to the power 2, that is this power 2 is said to be the dimension of length. So this is considered to be dimension. Dimensional formula, by using this dimension we make the dimensional formula. What do you understand by dimensional formula? The expression which shows that which of the fundamental quantity with what powers enter into the derived unit of physical quantity, it is known as the dimensional formula of that physical quantity. For example, area we have taken. So area is equal to length into breadth. It means that length is also considered with L, breadth is also considered with L, because in breadth also we measure the length only, okay. So L into L, that is L square. So we write this formula, L to the power 2 is there, but there is absence. We in dimensional formula we consider 3 basic quantity. Number 1 is mass, number 2 is length, and number 3 is time, okay. So there is absence of mass in this formula, area. There is absence of time of this in this formula, area. So we use only L to the power 2, but in case of writing dimensional formula we denote all 3 terms, mass, length and time, but there is absence of mass there. So we write m to the power 0 or not, L square and t to the power 0. In this way we write this dimensional formula. So this is the way how to write the dimensional formula of any physical quantity. Dimensional equation is what actually? The equation obtained by equating the symbol of physical quantity with its dimensional formula is called dimensional equation. For example, we are taking area. Area is a physical quantity, means derived quantity it is, okay. So area is a physical quantity. So area A is equal to how much? Its dimensional formula, m to the power 0, L square and t to the power 0. So this will become the equation, dimensional equation. So A is a physical quantity which is taken in LHS side, and its dimensional formula is taken in RHS side. Next we see here the principle of homogeneity. It is related with the dimension only and dimensional formula only. So according to this principle, dimensions of the fundamental quantity of 2 sides of physical relation must be same. Means both sides, if we are using the dimensional equation there, so both side means in LHS side and RHS side, if the dimensions are equal, okay, this is the principle of particular homogeneity, and is called as the principle of homogeneity. Means equation is there, in that case of equation both sides, both dimensions of both sides must be equal or equivalent, okay. Example is given for the relation. We just compare both sides by using its dimensions. So fundamental quantities are there. For example, in one side we have taken m to the power a, L to the power b and t to the power c. Similarly in RHS side, m to the power x, L to the power y and t to the power z. In this case the dimensions are equal. It means that the powers of both sides must be equal, that is a must be equal to x, b must be equal to y and c must be equal to z. This is said to be the principle of homogeneity. Let us see now how to make the dimensional formula of some physical quantities. So let us go through this, and I'll just show you how to make the dimensional formula, okay. We take some physical quantities here, okay. For example, here if we take number 1, area. Area means length into breadth. So length also measured in length, breadth also measured in length. L into L is L square, but dimensional form we write m to the power 0 L square and t to the power 0, and its unit will be m square. So in case here unit, we use the unit of the area will be m square, because its dimensional formula is m to the power naught L square and t to the power naught. Next we take volume. Volume is actually what? Area into length. Area we have already, the dimension form of area is L square, and again for length we use L. So L square into L is equal to L to the power 3. We write its dimensional formula. There is absence of mass, m to the power 0 L cube t to the power 0, and its unit will become m cube m to the power 3. That is the unit of volume. Density, general formula of density is mass upon volume. So unit for mass is kg, unit for volume is meter cube. So its unit will become kg per cubic meter. But how we make the dimensional formula? In place of mass we put m, and in place of volume already we have taken out volume here L cube. If we take L up, its power will become minus. So m to the power L m L to the power minus 3, and its dimensional formula final will become m L to the power minus 3 and t to the power 0. This will be the dimensional formula of density. Similarly for speed, distance upon time L upon t, L t to the power minus 1, m naught L to the power minus 1 is the dimensional formula of speed or velocity, and its unit will become meter per second. So meter per second is the unit of speed or velocity. Acceleration, velocity upon time. So we see here L t to the power minus 1 is the velocity dimensional form upon t, that is t. If we take this t up, the dimensional form of acceleration will become L t to the power minus 2 m naught L to the power minus 2. This will be the dimensional formula, and unit of acceleration will be meter per second square. Linear momentum, general formula for the linear momentum is mass into velocity. So m into L to the power minus 1, and this will be the dimensional formula. Its unit will be kg meter per second. In this way we can form the dimensional formula of different physical quantities. Force is here, mass into acceleration. For mass we write m. For acceleration we have this dimensional formula written here, L to the power minus 2. When we combine, we will get this dimensional formula, m L t to the power minus 2, and its unit will be kg meter per second square. Okay. Impulse, force into time. So force formula we know that m L t to the power minus 2 into time, t is there, so it will become m L t to the power minus 1, and its unit will become kg meter per second. Work, force into distance. Force formula we know that m L t to the power minus 2. For distance we use L here, so m L square t to the power minus 2 will be the dimensional formula of work, and its unit will be kg meter square per second square. In this way we find out the dimensional form of it. Okay. These are general units for this. We can say that actually we just take the unit of work as joule and unit of force as Newton also. Okay. Pressure, force upon area. For force, dimensional form of force m L to the power minus 2 upon area L square. We will get finally the final dimension form of pressure will be m L to the power minus 1 t to the power minus 2, and its unit will be kg per meter second square. It will be the unit of pressure. For power, work upon time. So dimension form of work upon time, dimension form of work upon time, this t will go up, so it will become minus 2 and minus 1 will become minus 3 m L square t to the power minus 3, and its unit will become kg meter square per second square. It will be the unit of power. In this way some other physical quantities are there. We can find out the we can make the dimensional formula for this physical quantity by using the general formula also. Okay. So this is about the dimensional formulas of physical quantity. At last we come to this applications of dimensional analysis. There are generally 3 applications of this dimensional analysis. Number 1, conversion of one system of unit into other. Number 2, checking the correctness of the given physical relation. And number 3, to derive the relation between various physical quantities. Okay, so now we just go through this application of dimensional analysis one by one. So all of you, we have to use board there. So all of you please note down from the board one by one the applications of this dimensional analysis. So let us come to board now. Okay, so applications of dimensional analysis. First application we are going to see here. Its first application is conversion of unit of one system to other unit. So you'll have to note down this from board only. I'll just wait for some time. Okay, just after finishing this, one by one we'll go through all three applications of dimensional analysis. This is the first one. Okay, so how to convert the unit of one system into other by using dimensional formula. We suppose that systems, we have seen that systems, three systems are or four systems are there generally. Cgs system, Mks system, FPS system, SI system. Okay, so we see here, we take Mks system 1 Newton of force into how many dynes? So Newton is the unit of force in Mk system. Okay, and this dyne will be in Cgs system. So we have to find out in 1 Newton of force how many dynes are there. We'll try to convert this unit into Cgs, Mks to Cgs system. What is the way? So generally we write the dimension formula for Mks system. Suppose that number of times the unit is repeating n. This is n1. The dimensional formula of force is what actually? ml to the power minus 2. Okay. So here we say for Mk system m1 l1 t1 to the power minus 2. Now here we write here is equal to Cgs system. Unit for Cgs system, we suppose how many times it repeating is n times. Okay, number is n2 we say here, and dimensional formula is same as force, but the system is changed, so we write m2 l2 t to the power minus 2. We know that this number of times n1 is 1 only, so we write 1 here. We bring this term downward. We have to find how many times this dyne is there in Cgs system. So we have to find out this n2. We bring this term down here. So let us see n1 into m1 upon m2 into L1 upon L2 T1 upon T2, and power is same there, minus 2, which is equal to N2. Okay. Now M1 for Mk system mass kg is there, and for Cgs system gram is there. For length in Mk system meter is there, for Cgs system centimeter is there. Time second, time is same in both systems, so we write S for both system, so we write the units here. N1 is 1 into M1 is kg upon gram, meter upon centimeter, second upon second to the whole power minus 2, and it is equal to N2. 1 kilogram, so we convert this kilogram into gram, 1000. Meter 100, centimeter. Second is cancelled by second, 1 to the power minus 2, which is equal to N2. Now this gram is cancelled by gram, centimeter is cancelled by centimeter. What do we get here? 1 into 10 to the power 3, 1000 into 10 to the power 2, 10 to the power 3 into 10 to the power 2, it will become 10 to the power 5. So N2 value is equal to 10 to the power 5. So we can write here the value of N2 we are getting here 10 to the power 3 into 10 to the power 2, that is 10 to the power 5. So we write N2 as 10 to the power 5. So we can say here 1 Newton of force is equal to 10 to the power 5 dyne. So this will be our answer. In this way we can write 1 Newton is equal to 10 to the power 5. Okay, in this way we can convert the unit of one system into other. Okay, so this is the first application of dimensional analysis. Let us go through the second application. Second application is checking the correctness of equations. Whether this given equation is correct or not, we will have to check it. In between you may pause and just note down this. Okay, so you please note down this. This is 1 Newton is equal to 10 to the power 5 dyne here. Let us now go through the second application. And second application we are checking the correctness of given equation. Checking the of given equation. This is the second application of dimensional analysis. Okay, let us suppose that any equation we want to check whether this equation is correct or not. We take that work is equal to change in kinetic energy. This is the work energy theorem. Change in kinetic energy is equal to half mv square minus half mu square. Okay, this is given equation. We have to check whether this equation is correct dimensionally, it is correct or not. Okay, so now we'll one by one we'll just go through what is the formula of work actually, or dimensional formula of work also we may write. Dimensional formula of work we know that ml square t to the power minus 2 half. For mass, dimension of mass is said to be m. For velocity, final velocity it is, so velocity L to the power minus 1 to the whole power 2 minus 1 by 2. Again for mass, m is there. Initial velocity, actually initial velocity is also velocity, so its dimensional formula will be same, L to the power minus 1 to the whole power 2. Finally we write here half m L square t to the power minus 2 minus half m L square t to the power minus 2. So here also in LHS side we are getting the dimension ml square t to the power minus 2. It means that according to the principle of homogeneity, the relation, physical relation is here, and in physical relation LHS, the dimension of LHS side and the dimensions of RHS side are equal. Okay, you can see that when we compare this, the dimensions are equal. So dimensionally both sides are equal. So it means that the given relation or given equation is correct. Since by principle of homogeneity, both sides are dimensionally correct, therefore this equation is correct. So in this way we can check the given equation by using dimensional formula. All of you please note down it. Then we will go through the next application of dimensional analysis. Okay. So, we will go through the last application of dimensional analysis, and this is to derive the relation between various physical quantities. Whether the given relation is correct or not, we have to derive it. Or what is the relation? We have to derive the relation. Relationship between, derive the relationship between various physical quantities. Okay. Let us suppose any term f is proportional to m to the power a, v to the power b and r to the power c. F is supposed to be force, is directly proportional to m to the power a, v to the power b and r to the power c, where m is mass of an object, v is velocity of an object and r is the radius of circle. What will be the relation between this? Let us find out by using the dimensional formula. So, we write here f by taking out this proportional sign, we keep here constant k, m to the power a, v to the power b and r to the power c. What is the dimensional formula of force? Dimensional formula of force is m to the power m l to the power minus 2, which is equal to, here k is constant, m means mass, m to the power a, velocity, dimensional form of velocity, L t to the power minus 1 to the whole power b, and r is the radius, that is distance only, so L to the power c. So, we have written all these three terms in dimension form, m to the power a, L t to the power minus 1 to the whole power b and for radius L to the power c here. Now, you can see this. The power of mass is 1 here, the power of length is 1 here, L is 1 here and T is minus 2 here. Here we can just see what will be the power. Constant m to the power a, L to the power b and L to the power c. So, L to the power b into L to the power c into T to the power minus b. Okay. We will get this constant k m to the power a into L to the power b plus c into T to the power minus b here. Okay, this is minus b. Now, here we write this dimensional form m L to the power minus 2. By comparing the powers of both sides, okay, of physical quantities, here mass to mass, L length to length and time to time, we will compare their powers. Okay. By comparing the powers, what do we get? M to the power 1 and A. So, here we are getting A is equal to 1, equation 1. L power is 1 and L power is B plus C. So, we write B plus C is equal to 1, equation 2. T to the power minus 2 is equal to minus B. So, we write here minus B is equal to minus 2, minus is cancelled by minus, this is equation 3. So, out of these three powers A, B and C, we got the value of A is equal to 1 and value of B is equal to 2, but value of C we have to find out. We put the value of B here. When we put the value of B here, we will get 2 plus C is equal to 1. It means that C is equal to 1 minus 2, which is equal to minus 1. So, the value of C we are getting minus 1, value of A is 1, value of B is 2 and value of C is minus 1. So we place this powers value of A, B, C here in this format. Okay. We come to know that what is actual relation. F is equal to K into M to the power A is 1, V to the power B is 2 and C to the power minus 1 means R to the power minus 1. Okay. Minus 1 means it will go down. It means that force F is equal to K into mv square upon R. So by using this dimensional formula, we got this relation F is equal to constant K into mv square upon R. So force F is equal to mv square upon R. What is this actually? This is a centripetal force. Okay. So this is centripetal force. So in this way, by using the dimensional formula, we can show the or derive the relationship between the various physical quantities. So this is the last or third application of dimensional analysis. All of you please note down from the board. Okay, note it down. Okay, and copy it. Okay, so these are the some applications of dimensional analysis, and that's all for this video, today's video. Okay, now we'll go through the next topic, last two topics of the chapter number 2, significant figures and the errors. We'll take in next video. Till then, all of you stay safe, stay healthy. Goodbye. Thank you.